right, so we are looking at the definition of the derivative. What's really nice about the definition of the derivative is that it is a modified version of instantaneous tangent line. So we're still going to have the limit as h approaches 0. We're going to still have f of a plus h minus f of a all over h. We're just going to now know it and understand it as the definition of the derivative. A derivative in calculus is a representation of the slope or the rate of change of the function. So if your function is linear, so let's say the equation is 2x plus 1, then the derivative is the slope of that linear function. So it's the slope of 2x plus 1, 2. So the derivative of 2x plus 1 is 2, because it is the slope of the equation you know. So finding the slope or the derivative of a linear function is really easy, because you know what the slope is. What happens in calc, we don't just find the slopes of linear functions, we find the slopes of complicated functions. So we find the slopes of cubics, we find the slopes of quartics, we find the slopes of square roots, of absolute values, etc. So in order to be able to talk about it, it's important to understand what slope is. So if I gave you a very original graph of a function that is clearly a piecewise, because it is many functions pieced together, you have a constant, which is a horizontal line, you have a decreasing line, you have an increasing line, and then we have a parabolic. So what you would do is look at the graph and it says, what is the slope of f of x at x equals -3? So you would go over to your graph, you would go to -3, look at the graph at that point, and what is the slope of a horizontal line? 0. What is the slope at x equals 0? So what we would do is go to our graph now. Now we're looking at the slope of this line segment. So you're looking at the line segment that crosses x equals 0. And we know slope from a graph is how many do we go down, how many go over, through like all of the nice pretty points. So this line is going down 2 over 1, down 2 over 1. So if it's going down 2 over 1, the slope of the line is -2. Perfect. Okay, the slope of the line at x equals 2. So again, now we have a new piece to our graph. We're now looking at this line segment over here. So the slope of the line at x equals 2 is the slope of that line segment. So that line segment is going up 1 and over 3. So the slope of the line, if it's going up 1 and over 3, is 1/3. You guys are so smart.
Could be geniuses, actually.
What is the slope at x equals 6? So did anybody in here at any point in time take AP Physics? Like even out, like 1, yeah? Okay, so then think about that as like a function that is being launched from rest, going up, and then coming back down. So like the velocity is kind of the slope. So what is the velocity, or what would the slope be approximately at x equals 6? So this time we can't calculate it the same because it's not a line. So we're going to have to predict it. So what you would do is almost draw in your tangent line. So you'd say, okay, the line needs to be there. If this would represent the velocity, obviously we don't know the curve, so we can't calculate the velocity. So the first thing I should know is my answer better darn well be negative. It's going down. So at least give me that it's negative. And then if I'm trying to really look at this, oops. I'm thinking this line kind of goes like this. So, kind of going down 2 over 1. That red line almost kind of looks parallel to that yellow line, right? With the red and yellow on my graphs. So I'd say this is pretty close to -2 again. Okay,
I like this question.
what about finding the slope of a function at a point? So let's look at this visually. My link isn't going to work when we have a shortened period. If you really want to see it, you can type that in and go to it later on your own. But all it does is like move tangent lines along the curve. So you can like kind of see it yourself. So I can send it on Teams, and if you want to play with it, you can. But just because we have shortened periods today, I'm going to nix my Desmos. So you have a function f of x equals x squared minus 4x plus 4. Find the slope of the function at the point 3, 1. What is the equation for the slope? So, if you go back to what we know how to find the slope at a point for a function. It is the limit as h approaches 0 of f of x plus h minus f of x. Or, because it's at a point, you can use the other formula. So you could do the limit as x approaches, and a in this case would be 3 of f of x minus f of 3 all over x minus 3. So if you like the h approaches 0, you can do it that way. If you like the x approaches a, you can do it that way. So in this case, it would be the limit as x approaches 3 of x squared minus 4x plus 4 minus 3 squared minus 4 times 3 plus 4 all over x minus 3. So 3 squared is 9. 4 times 3 is -12 plus 4, well, 9 and 4. Technically, if you want to, you can distribute your negative, positive, negative. So those two 4s can cancel. And then you're left with -9 plus 12, which is positive 3. So now you have the limit as x approaches 3 of x squared minus 4x plus 3 all over x minus 3. So then we're going to say that that is the limit as x approaches 3 of x minus 3, x minus 1 all over x minus 3. We have removable discontinuity at x minus 3. And we get the limit as x approaches 3 of x minus 1. So it's really 3 minus 1, which is 2. So what that means is that the slope through this point is 2. And again, if I drew that in, you can almost see that. It's going up 1, and if that line continued, up 1, 2, over, oops, it's more like 1 to 1. That line is a little off. Probably should have been steeper. That's all. So what is the equation for slope? The equation for slope is one of our two limits. So limit as h approaches 0 of f of x plus h minus f of x all over h, or limit as x approaches a of f of x minus f of a all over x minus a. Okay, let's alter that so that our second point is h units away from our given point. So x equals 3, so my new slope becomes what? So now we're not finding it at that particular point. Now you're finding it out in general. So if you have a point at 3 and you have a point at 3 plus h, what is that now finding? What's that green line represent? So if you have a point and you have a point h units away and it goes through 2 points on your graph, not just one, that is the secant. So now that 3 plus h would represent the slope of the secant. So that new slope becomes this. Another word for slope of the secant is average rate of change. So another way of interpreting the slope of the secant is by saying the average rate of change and in the case of this, it would be the slope equals f of 3 plus h minus f of 3 all over 3 plus h minus 3. And do we want to suffer through plugging 3 plus h into that original quadratic? Because again, we're still talking about this f of x, x squared minus 4x plus 4. So algebraically, that would be like plugging all of this in to that. So it would be 3 plus h squared minus 4 times 3 plus h plus 4 minus, we already found f of 3. We found f of 3 over here. F of 3 technically didn't simplify to 3, simplified to 3 minus 4. Which eventually simplified because the 4's and the stuff canceled. So f of 3 was really 9 minus 12, which was negative 3, plus 4, which was 1, and then the minus 1 here. So this is really like minus 1 all over. And what happens here? You have 3 plus h minus 3, so we get h. So now you have 9 plus 6h plus h squared minus 12 plus minus 4h. 4 and negative 1 is positive 3 all over h. So 9 minus 12 is negative 3. Negative 3 plus 3 is 0. So you have 6h plus h squared minus 4h over h. Technically 6h and 4h was 2h. And then technically you have an h in every term. So we have 2 plus h. So the slope of the secant is 2 plus h. Is everybody okay with that?
I just did it for the 4x. So I realized I didn't plug in all the numbers.
I know, I had to go back and look at it because I was afraid I was going to copy it wrong. That's what I was my cheat sheet. No, I didn't save this last year. Okay, moving that second point closer to the point 3, 1 makes the h value closer and closer to 0. So as my h value gets closer and closer to 0, it makes the slope of the function the same at that point. And we know that that is the tangent line. So if we get closer and closer and we're making the h value 0, then that purple line becomes the tangent line. So that makes this the instantaneous or the tangent line. Now in calculus, instead of calling it the slope of the tangent, we are going to call it the derivative. So now you know what the derivative is. The derivative in calculus, anytime you hear me say derivative, you are automatically thinking rate of change. In calculus, a derivative is a rate of change. In calculus, a derivative is a rate of change. Limits are so popular in calculus that they have this special name, and that name is the derivative. We are eventually going to learn how to find f prime of x without a limit. We're going to learn special formulas. So the limit only exists for one more lesson, and that is 2.1, maybe 2.2. But after that, the limit's going to go away. We're going to learn all these things called the power rule, the chain rule, the quotient rule, the product rule. And you're going to be like, and you made me do limits for 3 weeks, Mrs. McBride? I'll be like, yep. Because somewhere on that AP exam, on a free response question, you will have to take the formal definition of the derivative, which is on the board right here. That is what you know now as the definition of the derivative. The limit as h approaches 0 of f of x plus h minus f of x all over h is now known as the definition of the derivative. So what do we know about the derivative itself? Well, we know that the domain of a derivative is the same as the domain of the original. The derivative's domain can be smaller than the original, but it can never be greater. So the domain of the derivative will be smaller at times, but it can never be greater. So if like the domain of the original function is x greater than or equal to 1, the domain of the derivative cannot include 0. If the original doesn't include 0, the derivative can't include 0. If f prime exists, then we say that f has a derivative at x. You will also hear me say that that means the function is differentiable. So the word differentiable simply implies that it has a derivative. The word differentiable means that it has a derivative. So a differentiable function is a function that is differentiable at every point on its domain, or in layman terms means it has a derivative. A function that is differentiable has a derivative. So that means just like not all functions are continuous, not all functions have derivatives. Not all functions, or they might have a derivative, but not on its entire domain. The derivative might have a restricted domain. Just like in other math, there are 1,000,001 ways to represent the derivative. So if you go back to like the days in algebra, sometimes we wrote y equals mx plus b, and sometimes we said f of x equals mx plus, and just to be fancy, we change it to an a. But they meant the same thing, right? Like the m's represented the slope, the x represented the x, the y and the f of x were interchangeable, and a and b were really just numbers. So in calculus, there are about 4, on average, different ways to represent a derivative. Y prime is nice and brief, but it doesn't tell me a variable that is considered to be the independent. So y prime is like the lazy derivative notation. dy dx is the most common and one of the most informatives. It tells you that you are taking the derivative of y with respect to x. So we're deriving the x's and y's together. So it names both variables and it uses the d for derivative. So it's the first derivative of y with respect to derivative of variable x. df dx means that you're taking the derivative of the function f with respect to variable x. And then sometimes directions will say d dx of f of x, which also means you're taking the derivative of f at x. It emphasizes the idea that differentiation is an operation performed on f. So again, this one is more implicatory that it is an operation. The other one that's not up here, but kind of flows or goes in between these two, is f prime of x. So it's like a combination of those two. Here's the function, and it tells you you're deriving with respect to x, but it doesn't give you the y. Hello? Hi. I'm doing well. How are you?